10.1. In this section, we're going to look at composition functions and inverse function. The inverse function is important for the following sections in this chapter. Composition functions is basically a functions within another function. That's what we're going to look at it first. Okay. So a composition function is basically something like this. You have a function within the functions. So usually we do the input value x, right, into a functions. So therefore the outcome, the output value will become g of x. And what we're going to do is we use this output value, substitute into another functions. So this output value g of x become the input of another functions. So what happened is the outcome will look like this, a function within another function. So a function within another function. So according to the definitions, we use this notations. F of g of x, it is not a dot, it must be a circle, okay, of g of x. That basically means you are substituting g functions into f function. So it's very important that you write the notations very carefully on the computational part. So let's take a look at on this example. So f of x is 3x minus 2, g of x is 5x plus 1. And we are interested in looking for f compose g of x. So according to the formula definitions, equivalent formula will be f functions, the input will be the g functions. We cannot substitute this g of x notations, so therefore what happens is we're going to replace this g of x notation with its formula, which in this case the formula for the function g of x is 5x plus 1. And this kind of problem we did it before in a functions session, right? Now we have f functions, the input is 5x plus 1. So when we evaluate this, remember this is how I asked you to practice writing. F function, the formula is 3 times the input minus 2. Now I can clearly see where my input's gonna go, which is 5x plus 1 right here. After substituting it, all we have to do is simplify. Distributing 3 will be 15x plus 3 minus 2. So my final answer will be 15x plus 1. This will be the final answer. So strictly follow these steps, okay? That will help you to make clear on how to write this composition function. So let's take a look at on the next example, part B of this example. This time, g compose f of x. So that tells me, according to the definitions, the second function is the input of the first function. So we know we have g of x, the input will become, this time, f of x. And as usual, as in previous example, we cannot use this f of x notations to do the evaluations. So therefore, replacing this f of x with the formula. So the formula for f of x is 3x minus 2. Now we know that our input has a binomial expression for g function. So evaluating g functions at this input, we know that the g function, the formula is 5 times the input plus 1. So in this case, my input is 3x minus 2. So simplifying this will become basically distributive 5, 15x minus 10 plus 1. And then combine like term, that will be 15x minus 9. That will be the final answer. Lastly, evaluating g compose g of negative 1. So that is g functions. My input will be another g functions, but evaluating at negative 1. So the first two example is in general case because we are talking about evaluating at x. X can be any number. This last example is in a specific x value. That's what we are interested in. So like before, to make it everything nice and neat on the writing part, we're gonna evaluate this g of 1 on the side work. So what is g of negative 1 equal to? The g function, the formula is 5 times the input plus 1. So in this case, my input is negative 1. So that helps us to get negative 5 plus 1, which is negative 4. So now we know that g of negative 1 is equal to negative 4. We're going to replace g of negative 1 with negative 4. So now it's basically asking you to evaluate g function again when the input is 4. So therefore, on the side work, g of negative 4, that is equal to 5 times negative 4 plus 1, which is negative 20 plus 1, that gives me negative 19. So this gives us the final value, negative 19. So now, pause and then try this example too. Okay, see you can write it out step by step properly or not. So first questions, example 2, is f compose g of x. So let's check on this one. So f compose g of x, that means f functions, my input function will be g of x. And again, on the evaluation part, I cannot use g of x notation, so I'm going to be substituting this g of x with its formula, which is, in this case, will be 2x plus 5. Now we know how to evaluate this for f functions. So the formula for f function is input square minus 9. And the input is 2x plus 5. Finally, I can use my shortcut formula to simplify this. Using the shortcut formula, first square, first time last, double it, so it will be 2x times 5 is 10, double it will be 20x, and plus last square, minus 9. So therefore, my final answer will be 4x squared plus 20x plus 16. That will be my final answer for this section, for this problem. Next, composing g of f of x. So we are composing g of f of x. So that means g functions, the input function is f of x. As in previous examples, I cannot evaluate this notation f of x, so I'm going to replace this f of x with the formula, which is x squared minus 9. Now, evaluating g functions at this input x squared minus 9. So the formula for a g function is 2 times the input plus 5. We know that our input is x squared minus 9. So finally, distribute it to x squared minus 18 plus 5. Combining like terms, that gives me 2x squared minus 13. Lastly, I want you to find f compose f of x, f of 2. So that means the f functions, the input is f functions evaluating at 2. So like before, I'm going to try to compute f of 2 on a side work so that it will be, the format will be nice and neat. So my f functions, the formula is input square minus 9. So it'll be 2 square minus 9 is 4 minus 9, which is negative 5. So finally, I know that f of 2 is equal to negative 5, so I replace it f of 2 with 5 in the original problem. And final answer should be f functions evaluating at negative 5. So f functions evaluating at negative 5. That is input square minus 9, which is negative 5 squared. That will be 25 minus 9, which is equal to 16. So I got my answer 16 on this problem. And that is the composition functions.